Congestion management, the implementation. Well, we've come to the point where we've gone through the concepts and design of the congestion management methods, really ending up on low latency queuing, which is the culmination of all the legacy queuing methods, priority queuing, custom queuing, and weighted fair queuing in one mega queuing method, with some enhancements added. So we're going to take a look at that as we go through and set up low latency queuing from end to end in this nugget. And what I'd like to do is kind of bring us to a point of solid configuration. I just want to spend this entire time going through a solid configuration of quality of service from end to end, using all the concepts that we've seen in this series up till now. Classification, marking, queuing, deploying all those queuing mechanisms, N-bar, classifying the traffic. It's going to be cool. And I'm telling you, I didn't realize just how valuable this kind of stuff was until I saw somebody doing stuff, and they actually sat with me and explained to me, hey, you know, this is why I'm doing this is why I'm doing that, and I thought this is the way to learn. So that's why I'm excited to get going with this. I have to confess, there will be some firsts for me in this nugget. I am using, drumroll please, an Apache web and FTP server to run kind of the server side of things, and it's the first time I've ever used a Unix or Linux application on my Macintosh that I bought to learn Linux, and I've pushed it off, so I'm really excited to see Apache work as well. So here we go, let's get going. This is the story. We have, over on the left side of the screen, a client PC, and this is going to be a client that's just doing normal activities, such as downloading web traffic, accessing FTP services, and so on. And I've set it up to where they're going to be using this as their default gateway and going through this cloud, which is going to be the connection between router 2 and router 3, to a server over on the back end. This is the Macintosh server running web services and FTP services, and I have some VNC remote desktop control happening so I can access this server remotely and so on. But I'm going to have this stream of traffic going through between these ends. Now, nothing special is happening on the routing side. It's just static routes allowing this router to know that this subnet is back here and this static route to know this subnet's happening. So nothing really fancy is going on. So what I'd like to do is I'd like to just go ahead and bring up my web browser, and I'm going to access that Macintosh web server, and there it is, Apache, it works. And I'm going to go, I put a file in that web directory called archive.zip. Now this file is 148 megs, and I have the link speed configured to go about half a meg, 500 kilobits per second or so of bandwidth that we have enabled on there. So I'm going to save this file to my disk, and 148 megs across that kind of link should take a good, well, not as long as I thought, but a good time to download and give us a constant stream of traffic running throughout this entire nugget. I'm going to minimize that, and go ahead and bring up the second side of this, the FTP server. I'm going to FTP over to that same device, 172.30.1.10. That's the web server right up here in the upper right. And I'm going to log on as me. I'm now in the FTP services for the server. I'm going to just do a listing on that directory, and I also put in here the same, let me see if I can find it, the same archive.zip file. So I'm going to download that as well. So I'll just go ahead and type in git archive.zip. Excellent. We now have two transfers going on, going from one side of the network to the other, and eating up bandwidth on these links. And I just want to get a good feel here as well for the speed that we're getting on that connection, because it should drop down now that our FTP session is over, or starting. And you can see, sure enough, the kilobits are dropping 0.3 kilobits at a time, dropping down because now that bandwidth is shared between FTP and HTTP. Good. So as time passes, we should start seeing that even out. Probably, my guess would be around 30 or 40-ish kilobits per second for both sessions going through, because they're just using best effort delivery to get there. Okay. Now with that in place, let's bring up the router side. Through an access server, I have a console connection over to router 3 on the left-hand side of that screen. Oh, let me get my windows brought up here. Router 3 is what I'm plugged into right now. And the first thing I want to do is I want to go under their interfaces. Let's just do a show IP interface brief there. And you can see that I have the Ethernet 0 with the IP address we would expect to see, serial 0. I want to go under that serial interface. and turn on a feature we talked about early on in the series called NBAR Protocol Discovery. I'm going to type in IP NBAR Protocol Discovery. Now, if you haven't checked out the classification nuggets, you might want to check that out because we talked about how NBAR has this built-in monitoring feature that allows us to see the traffic that's happening on our network in real time. I'm going to exit out of there, and I want to hop over to router 2 as well. Jump into global config, interface serial 0/0, and turn it on this side. I'll type in IP NBAR Protocol Discovery to allow the protocol discovery functionality to be enabled there. And it's taken a moment because this is the first time I've set it up. I'm also going to type in load interval 60. By default, NBAR will monitor that session for a 5-minute average of the traffic. This will lower that average to once every minute. So when I'm looking at my traffic statistics, which I'm going to exit out here and I'm going to type in show IP NBAR Protocol Discovery stats, and it would be the bit rate, and I want to see the top 10 senders on the network. And by golly, that is quite the long command. So I'm going to go ahead and highlight that, hit Control, or actually just right-click. Right-click copies into the buffer. I'm going to create an alias. Alias exec. When I type in traffic, I want it to do that command. So that way we don't have to type it all the time. Now you can see that right here I have web traffic that's going through, getting about 139 kilobits per second, and I just turned it on, so I have a feeling that that average will go up. Let's go ahead and type in traffic one more time. And we see right there, HTTP, it is going up. We are getting a kind of a good feel for input coming into that interface, what we're getting. Now, remember, direction is very important here. We have web traffic that is coming from this server through this router being input on this interface on router 2. So it's coming input into the router. Output is going to be very low because I'm not sending much in the other direction. Let's hop on over to router 3. And I've created the same alias over here. I'll type in traffic. And over on this side, we see on serial 0/0, FTP is recognized on the output direction. And you notice sometimes it'll show up as unknown on the other side. The reason why is we're using dynamic port numbers. Sometimes NBAR is not able to reconcile what port number they're using depending on the direction that we're going. Router 3, sure enough, is able to find both HTTP and FTP being sent out the serial 0 interface towards this client. And you can see they're dividing up my 512 kilobit per second connection pretty darn even. So that's the status of the network as it is right now with file transfers going. Now what I want to do is on top of this, I want to start adding our marking and queuing mechanisms. So the first thing we want to do is get into global configuration mode. As we get into there, I'm going to create a class map, and let's go ahead and say this class map will be named Match HTTP. And what I'm going to do is use NBAR to match that protocol. I'm going to say match protocol. As soon as I use that protocol keyword, NBAR is engaged. It's much easier than using an access list. And the protocol I'm going to be matching is, sure enough, HTTP. You see it right there in that list. So I've got the first class map created. I'm going to create a second one. Hit the up arrow, and we'll call this one, guess what? Match FTP. I'm going to create a match protocol FTP statement in there, so now I'm able to catch both of them. Exit out on there, and we now have the class maps created. I'm going to do a show class map, and we have the class default, which is built into the router, matches everything. Match HTTP, match FTP, we're good to go. Now, from here, I want to create our policy maps. Let's go ahead and say policy map mark traffic. The first thing that I'm going to do is implement traffic marking mechanisms, because when it gets to this router, you saw router 2 was having a little difficulty recognizing FTP because the port numbers are dynamic. Some of the NBAR features only recognize port numbers, so it was categorized as unknown. If I turned it on both interfaces, both the serial 0/0 and Ethernet over here, you would see it recognize it as FTP as it passed out the Ethernet 0 interface. But on the input direction, it's using strange dynamic port numbers that are changing all the time. So NBAR will catch it. It's just what interface it'll catch it on. So I'm going to mark it to make it easier for router 2. I don't want router 2 to have to use nbar at all to figure out what kind of traffic is going through. I just want it to be able to match the markings. So I'm going to say for the policy map mark traffic, I'm going to go under the class match HTTP. Now under this class, what are we going to do? Well, we're going to mark the traffic, and the way we do that is by using the set command. I'm going to say set, and I want to use, I'm going all out here, DSCP, the big guns for our marking. I've got DSCP, and I want to use, well, let's go ahead and mark web traffic with AF21. That's essentially IP precedence 2 with a very low drop value. So AF21. So I've now said that's what I want to do for the class HTTP. I exit out, and I'll say for the class match FTP. Now remember, we're still in the same policy map. Oh, flip my screen here. The same policy map here, guys. It's still the policy map of mark traffic. And we're just going for separate classes under the same policy map. If you remember, policy maps can have up to 256 classes underneath them with different strategies and different methods that we're using for each and every class of traffic. So for the class FTP, I want to set, oh, caps lock is on, set DSCP. And for FTP, you know, I don't think that's as valuable as HTTP, so I'm going to give it AF11. That's about as close to as low as you can go. Well, I guess AF13 with that high drop preference right there would be as low as you could go without dropping to 0. But AF11 is pretty darn low. We've got an IP precedence of 1 that we're categorizing, and that's what we've categorized right there. So I'm going to jump back to global config mode, and I'll just do a show policy map. And let's see what we have here. Policy map mark traffic. For the class match HTTP, which very well does that using nbar, I want to set the DSCP value to 21. For the class match FTP, I want to set the DSCP value to AF11. So we should be good to go. Let's jump under the interface. Now, marking is typically done on the inbound direction. So in this case, I want to do it on my Ethernet 0 interface. I'll do a show IP interface brief there. There's our Ethernet 0/0. And I'm going to do a service policy, and the direction in this case will be input, because it's going to be coming into the Ethernet 0 interface from our server back there. And the policy that I want to apply is mark traffic. It is case sensitive. So we now have the policy applied, which is marking all of our traffic as we go through this device. So let's go ahead and jump back out to privilege mode. I'm going to pause the recording for just a moment. Give it a moment to see these counters increment, because traffic is flowing. Let me just pull it up, make sure we're still going. Sure enough, you can see my web traffic is flowing at around 33 or so kilobits per second. FTP, pull that up. It's still downloading archive.zip. So we'll give it a sec for the counters to increment, get a little marking happening, traffic is being marked, then we'll come back and verify that everything is going okay. Okay, I've let it run for about a minute. I paused the recording in that brief moment of time there, and it's been running for about 60 seconds, a minute and a half or so. Let's verify that things are happening. I'm going to use the show policy map command, and if you just type show policy map, all you see is your policy map that you've created. But here is the killer command, and this is, it is so great to see this, because Cisco has been very, I don't want to say inconsistent, but inconsistent over the years with their show commands. You have to do this show command to monitor this section of quality of service, this show command to monitor that section. Well, in the new world of the MQC standard, they've consolidated all the show commands under show policy map to really monitor what's going on. And I shouldn't say all of them, but the vast majority of them. I can just type in show policy map interface Ethernet 0/0, which is the interface that I applied it to, and watch what happens. I see all of the service policies that have been applied to this interface and what is happening for each one of them. Check it out. I have match HTTP as the class, and underneath there I've matched 6,376 packets, or looks like I'm close to about a megabyte of information or so. that I've matched underneath there. 779 kilobytes. 5-minute offered rate, the average rate is about 180,000 bits per second, or 180 kilobits per second that it's been using. And look at this. Quality of service, it is setting the DSCP value to AF21, and we have marked 6,376 packets. Now if we jump below to FTP, which is by nature a slower protocol than HTTP. I don't know if many of you knew that, but if you ever get the download option to download from HTTP or FTP, you should probably choose HTTP because it is a faster protocol. FTP, I have 500 or so kilobytes that have been transferred, 3,000 or so packets, and I've marked every single one of those packets with AF11. Now down here I have 4 packets, or 259 bytes, of class default traffic, and this is just anything that really didn't match anything. And as of right now, the main thing that's happening, I'm afraid to bring this up, this is a VNC session. You're seeing the screensaver through a remote desktop on my Macintosh. That is going to be what is matching in that class default right now. If I hit the up arrow, you're going to see, if I hit the space, since I maximized that class default, phew, it shot up. A lot more traffic was sent because it was starting to have to stream that screensaver one more time across the web, but across the web, this cloud, this test network. So we are successfully marking the packets coming from router 3 as they go out to router 2. Cool. Now let's hop over to router 2 and fill in the rest of our classification scheme. I'm going to, once they arrive on my router, I'm going to reclassify those into a class that allows me to then treat them as I would like to. Now again, this is not necessary. I don't have to use the markings that have been applied. I could use nbar to reopen the box, but I'm being sensitive on router 2 to my processor time. Since router 3 is putting the labels on the packets, they're sticking the labels AF11 and AF21 on all those packets going through, I might as well use those. So what I'm going to do is create a class map. We still need to classify. Doesn't matter if we've marked or not marked, we still have to classify. I'm going to do a class map, and we'll call it match AF11. And under here, I'm going to match the DSCP value. See that here in the list, DSCP, and we're going to match all the packets that come in that have AF11 as their tag. Exit back out. My caps lock is on. Sorry, I'll turn that off in just a moment. I just wanted to keep everything in capitals as I name everything. The other one is match AF21, and I'm going to type in match DSCP 21. AF21. Now careful. Typing 21 and AF21 are two totally different things for DSCP. So now I'll do a show class map. Make sure that we have the correct class maps defined. There was match AF21, match AF11, and now I want to apply the policy map. Now we can slowly begin to move from our classification scenario, where all we're doing is classifying the traffic and marking over on router 3, to implementing some low latency queuing to manage the congestion that we're experiencing right now. So on router 2, I'm going to create a policy map. Just going to type in policy map, and I will name it LLQ, because that's going to be the style of quality of service that I'm implementing here. Now I'm going to go under the class, and we'll say for the class match AF11. That was the class we created before to match all the FTP packets that have been tagged coming from router 3. For the class match AF11, in this case, I just want to guarantee FTP some bandwidth. So I'm going to say bandwidth followed by, and I can type it in whatever format suits me best. I can type in bandwidth and say I want FTP to get 8 kilobits per second, or I want FTP to be guaranteed, a certain percentage of the interface bandwidth. I want, 10% of that interface bandwidth. Those are pretty logical, and I really like using the percent, because what that means is I can reuse this LLQ policy. If I have multiple interfaces that I want to apply the same policy to, and they're differing speeds, typing in the kilobits per second kind of locks me in, because, on an Ethernet interface with 10 megs and a serial interface with 1 meg, the amount I guarantee to FTP may be different. However, if I use the percent, Aha! We can go ahead and say, I want FTP to get 10% of my interface bandwidth, and it will auto-adjust how much bandwidth it gets based on the bandwidth of the interface. So that's a killer command right there, is being able to reserve the percent. Now the other one I want to talk about while we're here is this remaining percent. Bandwidth remaining percent. And I can type in a certain percentage of the remaining bandwidth. If you remember, I talked about in the prior nuggets, the concept and design for congestion management. I said that Cisco has hard-coded their routers to keep you from reserving more than 75% of the interface bandwidth. Now, when you're reserving bandwidth for a lot of different classes, it's kind of hard to keep track of that. And it's kind of hard to go, well, you know, I gave 10% here, 20%. Have I reached that yet? So what you can do is you can type in bandwidth remaining percent. Now, the actual bandwidth that it gets assigned may be kind of hard to figure out if you do this. But if I say 10% here, what it will do is it will look at the 75% of the interface. And let's say, you know, not this example, but I need a whiteboard. I'm just waving my hands in the air. Let me grab my pen over here. Let's say that I have 75% of the interface bandwidth, and I've already reserved 40% for other classes. So that leaves me with 35% of the bandwidth remaining. This is my remaining bandwidth. So when I type in that command right here, bandwidth remaining percent 10, what I'm doing is I'm giving FTP or whatever class I'm under 10% of whatever is remaining on that interface. The advantage of doing this is that I'm never going to exceed my allocated bandwidth. I'm never going to over-allocate or over-reserve the bandwidth and go above the 75% because it will just take smaller and smaller chunks. It'll say, okay, 10% of 35% of the interface's bandwidth left equals this, and I'd have to get out a calculator. It's probably an easy calculation. I just can't do it in my head right now. So that's how we can reserve the bandwidth without exceeding that 75%. But it does get confusing as to how much bandwidth you're actually giving that class when you use bandwidth remaining percent. So I've given 10% now to AF11, right? That's using what quality of service mechanism? Think back. What quality of service mechanism am I using when I just reserve a certain amount of bandwidth for a traffic class? Now, you may have got it. It is class-based weighted fair queuing. That's the initial deployment. Before LLQ came out and added the priority queue to that, class-based weighted fair queuing allowed us to divide up all the different classes of traffic and reserve a certain amount of bandwidth for each class. Truth be told, we're really only using the class-based portion of that. We're reserving the bandwidth. Weighted fair queuing is typically turned on the default queue. Let's go ahead and add that feature right now. I'll exit out. We've done our bandwidth reservation for FTP. And remember, when we're doing this bandwidth reservation, that's not priority bandwidth. That's just bandwidth. It may be the first 10%, it may be the last 10%. All we're doing is guaranteeing that AF11, or FTP in this case, is getting 10%. Let's do the weighted fair queuing portion. I'm going to do a show class map so we can see the class maps we have. There's our class default, which is for everything else. So under the same policy called LLQ, I'll type in class default, and I'll type in underneath here fair queue, which allows you to use weighted fair queuing for this group of traffic. So now I've fully enabled class-based weighted fair queuing. Now we're talking about low latency queuing, and it's not low latency queuing unless we've turned on the priority queue. So let's do that. Now again, I don't have streaming audio or IP phones. I just want to show you the concept of this queuing using what am I using here? This demonstration. I'm just going to use web traffic to demonstrate how we can implement the priority queue. So I'm going to type in for the class, and what was that class called? It was AF21. So I'll copy that in there. For the class match AF21, I want to use not just bandwidth. but priority bandwidth. You see the strict scheduling priority for this class. And again, we have the same options minus the bandwidth remaining percent, because this never gets what's remaining. It gets the first percentage, or the first few kilobits per second of that interface. So when I type in priority here and I type in percent or kilobits per second, this is guaranteeing that AF21 marked traffic will get priority. This also brings me to the point of marking your traffic. A lot of people say, well, if I mark it with, EF, that means it automatically gets priority, or that's used for my voice, so it's going to get the priority. Well, remember, all the markings are just markings. What you do with them is a totally different scenario. I could go in and say anything marked EF is dropped if I wanted to. And at that point, I've reduced the EF marking down to dirt. And I could say, AF11 or DSCP0 is the one that gets priority bandwidth. The markings are just markings. What you choose to do with them is a totally another story. Now I want to do a bad practice here, because I want to show you what happens when you do this. I'm going to type in priority percent, and what was the max bandwidth that we could reserve? 75%, right? I'm going to reserve, let's type in 70. So we've now reserved more than the interface is meant to support. We did 70 for the priority queue, and we did 10% of the bandwidth for the AF11 group up here. Scroll up a little bit. A little more. 10% reserved for AF11 right there. So we've now reserved more than 80%. And you notice it let us do it. It let us, in the policy map, reserve that bandwidth. But watch what happens when we apply this. I'm going to exit out. And before we apply it, I'm going to do a show policy map. And right here I have LLQ, match AF11, bandwidth percent right there. Max threshold, this is how many packets it's going to hold in its buffers if there is congestion before it begins to drop. AF21 is strict priority, and it gets 70% of the interface bandwidth. Class default is going to be the flow-based fair queuing, which is essentially weighted fair queuing. And I'm going to get into the... Well, let me first show you the serial 0/0 interface. This is what catches a lot of people. You might think, well, I want, as traffic comes in, AF21 or EF or whatever class you're doing, I want that to be prioritized. So they'll type in, well, I want to do the service policy LLQ. That's the name of or service policy input LLQ. So as traffic comes into our router, we'll prioritize it. But the problem is, when you do that, it is only an output feature. Remember, your router is at the mercy of the upstream router. It's sending this traffic, and all you're doing is receiving it here. There's only 3 things that you can do on an inbound direction: classify, mark, and police. I can actually limit traffic as it's coming into my router, but that's it. I can't give priority because how can I do that? I mean, I'm receiving the packets in a certain order. This person is the one that determines what's being sent first. I can only turn on queuing in an outbound direction. So I'm going to go under my interface, Ethernet 0/0, which is the one connecting out here to this client segment. And I'm going to type in service policy output LLQ. Watch what happens. I hit enter. AF21 has requested 75% of the interface bandwidth, available only 65%. What's the story with that? Well, on Ethernet interfaces, they've said there's so much bandwidth there that you should only reserve 65%. The 75% rule applies to low-speed interfaces such as serial interfaces. And this is a fairly new rule. If you get into the older iOS versions, you'll find that even Ethernet interfaces had the 75% rule. But in this case, it's 65, so you look and you go, oh no, what can I do? It's telling me I can't do this. I can't reserve this bandwidth. Well, this is where you get to jump in and overrule the best practices. There's the command, max, and I'll hit the question mark, max reserved bandwidth. I can go ahead and type that command followed by what is the percentage of interface bandwidth that you want to be able to reserve. Well, if I'm a cruel and unusual administrator to my default class, I'm going to say I want to be able to reserve 100% of the traffic, which means you as the administrator can carve up that link 100%. Nothing else would be able to get through if all 100% was in use, so class default would starve in that case. But now I will be able, if I hit the up arrow, I will be able to apply that service policy without getting any error messages. It will apply that service policy. Now, the thing is, I just went ahead and said, FTP gets FTP gets 10% of bandwidth, and HTTP gets 80%. So I'd expect, going back to this, that this speed will start skyrocketing. It'll start going back up into the 60 when I started before the FTP transfer took place. But if you take a look at it, it seems, we're giving it some time there. It seems pretty solid. I'm still at 34.8. I'm not moving. You want to know why? Because there's no congestion right now on the Ethernet interface. Remember, congestion management, by the name of the word, congestion management only takes place when there's congestion. Where's the congestion right now? You got it, right here. The wide area network. We've got, let me grab my pen, I'm anxious, 10 megabits per second on that Ethernet interface that is flowing from here. This link between here is a 512 kilobit per second connection. So the congestion's happening here by saying that we've got priority. It's saying, you know what, you're not even congested here. I'm not even implementing these methods yet because you've got the full 10 megs. So we're not going to ever see any improvement looking at this web traffic unless we start implementing the management right here. This router is the one that's connected in the outbound direction to the congested link. So we need to hop over to router 3 and apply a similar policy. And guys, if you don't mind, I'm going to get a little crazy here. Crazy Jeremy. I'm going to hop over to router 3 and I'm going to create, let's go ahead and jump in here. Let me just do a show policy map just so I can refresh myself as to what's running over here. Okay, we just have the marking going. I'm going to jump into global config, create a policy map. We'll name it LLQ. And I'll say for the class, let's see here. For the class match HTTP, which it's going a little, doing this is not the best practice in the world because I'm now using the class match HTTP, which does what? It uses nbar to match my traffic. That's where I did the match protocol HTTP, and we've already marked it incoming on the Ethernet 0. So if I'm reusing these same classes on the outbound direction, essentially I'm taking marked packets that have been marked as they've gone mark, coming through, and I'm reopening them using nbar as they go out that interface as well. What I should do, if I was doing the best practice, is I would create two more classes, match AF21 and match AF11, and then I would use those as I'm going outbound so I can use the tags that I've applied. This isn't doing any damage to the packets or stripping off markings or anything. All it's doing is costing me a few more processor cycles on my router because I'm opening that packet twice, inbound and as it leaves eventually that interface. But for this sake, we've got plenty of processor power on tap. It's not a full production router. So I'm going to say for the class match HTTP, and this is where I'm getting crazy. I'm going to say priority 100 or priority percent 100%. I'm going to give, if HTTP needs it, I'm going to give them 100% of the interface bandwidth. Now let me ask you, what's going to happen to all other traffic when I apply this command? Well, you probably guessed it. It's toast. My remote desktop connection with the Macintosh is toast. It's frozen. My FTP session will eventually time out because HTTP will gobble up that bandwidth. And it'll take it a moment because it's going to slowly start increasing its window size as it realizes more bandwidth is available. But you will see our network brought to its knees by this policy. So this kind of demonstrates how we can use LLQ for the dark side. I'm exiting back out. I'm in global config mode. I've got the policy defined. I'll do a show policy map. Nope. I have to put the do in front of that. Do show policy map. Just to verify, we've got marked traffic on the inbound, LLQ on the outbound. So I'm going to get under interface serial 0/0. And first I'll show you the message if we try to reserve everything. I'll do service policy, output, LLQ. Saying, you're demanding 100%, I'm only allowing you to reserve 75%. There's that rule again. Oh, but we're the admin, right? We can get around that. Max reserve bandwidth, 100. Up arrow a couple times, applied. Now, let me go ahead and grab my window. Now we will be able to see, as it realizes, aha, I have more bandwidth, we'll start seeing this amount tick up. And this, Firefox is doing an average. You see it just went up. Ooh. It's doing an average over time. So as we would sit here for a while, you would slowly start seeing this kilobits per second adding up. You can see it 0.1, 0.1, because over the entire course of this nugget, it's averaged all this out. I'll show you a quicker way to figure out what's happening. I'm going to exit out, and you can see it slowly ticking up there. And I'm going to do a traffic, which uses N-bar. Now, this is a minute average, so wow, look at that. This is over the last minute, which FTP hasn't been totally cut out yet, but it'll get there. I'll keep hitting the up arrow. You're going to start seeing FTP slowly going down and down and down. This one's now up to 400 kilobits per second that it's consuming, and FTP is going to scrounge for whatever's left over, which won't be much by the time it's said and done. With this policy, FTP will eventually completely time out and eventually zero out on this scale. You can see how it's dropping. This is a 1 minute average, so it's going to go down to zero, and eventually my little FTP session right here will disconnect because it has no bandwidth left at all to communicate with the other side. Whew! I need to breathe. Give me a moment. Whew, almost had a heart attack there. I'm going to grab my cup of water and settle down a little bit. That is a full end-to-end deployment of congestion management using low latency queuing. That's using classification, in this case using N-bar, marking our traffic as it goes through, and then doing something with that marking using low latency queuing. I've got to be frank, I get pretty excited about that stuff, and congestion management is one of my favorite topics in quality of service because it gives you the most control over all of the traffic that's going through your network. So I think this is one of the killer apps of quality of service. So I hope this nugget has been informative for you, and I'd like to thank you for viewing.